means not only that I'll need my wizard hat, but also that it's an ideal time to talk about the outputs of a drainage basin. Drainage basins are often thought of as open systems, which means that water can enter or exit the system. The two processes by which water exits a drainage basin are evaporation and transpiration. Both of these processes can be thought of as a sort of anti-precipitation.
Action.
Evaporation is probably the more simple of the two concepts to grasp. You've seen it firsthand. If you've boiled a cauldron, steamed vegetables, or if your food has been a little too hot, you've seen the water vapour rising off the surface. That's exactly what evaporation is. Evaporation, in geography, is the conversion of liquid water into water vapour. Evaporation happens primarily in large areas where the water is relatively still, such as ponds, lakes, seas, or oceans. As we can tell from the fact that evaporation is more prominent at higher temperatures, evaporation increases the hotter the weather is. From a physics point of view, this is because the kinetic energy of particles within water increase as the temperature increases. But there is always a variance between the lowest and highest kinetic energies of particles. Those with higher kinetic energies, or those with kinetic energies high enough, can break free of the liquid water and evaporate into the sky. Now, there is always a variance, but at higher temperatures, the proportion of molecules that have high enough kinetic energy to vaporize, to convert into water vapor, increases. This is why there is always some degree of evaporation. It's also important to note that the drier the air is, the more evaporation there'll be. This is because there's more space in the air for the water vapor to take up. For the same reason, evaporation increases the faster the wind speed is. This is because the air with the water vapor inside it is quickly swept away and replaced by drier air with more space for water vapor. The last factor affecting evaporation is how much plant coverage the area has. This is closely tied in with temperature. When there's higher plant coverage, the sun cannot penetrate as easily onto the ground and the area is cooler. Thus, at higher plant coverages, there is less evaporation. So there'll be a lot more evaporation in a dry, hot, windy desert than in a humid forest, for example. Transpiration is the process by which the water inside plants evaporates into the atmosphere, mostly from their leaves. You will have learned of transpiration if you have studied under a Master of Biology. Like evaporation, transpiration tends to increase at hotter temperatures, at drier humidities, and at higher wind speeds, but conversely, it increases at higher plant coverages, obviously, since the water is coming from plants in this process. A useful concept to have in the study of geography is the combined effect of evaporation and transpiration. This is known as evapotranspiration. Evapotranspiration as a whole accounts for the loss of nearly all of the water that falls in arid areas and 3/4 in more humid areas such as this one. So, the river flowing down this mountain has already lost a proportion of its discharge and will continue to do so until it reaches its mouth. This seems rather counterintuitive, as a river tends to grow as it flows down its course. A river grows because it's contributed to by its tributaries and by the groundwater, at a rate which is usually faster than the water can evaporate. One final concept we must grasp in order to fully understand this topic is that of potential evapotranspiration. The concept is much more simple than its name suggests. All the potential evapotranspiration is an indication of how much evapotranspiration could occur given an unlimited supply of water. So, an exceedingly hot, dry, windy desert with only 2 handspans of water every year could have an actual evapotranspiration rate of 2 handspans, but a potential evapotranspiration rate of 20 handspans. This means potentially, if there were 20 handspans of precipitation in a given year, all of it would evapotranspire, and if 21 handspans of rain were to fall in a year, then there would only be 1 handspan left at the end of the year to flow into a river or gather into a lake. Effectively, there are only 4 things to remember. Evaporation is out of the ground, transpiration comes out of leaves and plants, evapotranspiration is the combined effects of both, and potential evapotranspiration is how much evapotranspiration there could be given an unlimited water supply.
I hope that I have enlightened you on the topic of drainage basin outputs. Come and meet me again soon, as I will create a highly accurate map based on the rules of trigonometry of an area of which I know no distance measurements. Until then, I hope that the continuation of your journey allows you to bask in the river of wisdom.